Hi guys, here we go again with me B. Villegas, Bachelor of Secondary Education, major in Mathematics. So, trigonometry substitution. So remember guys that it sometimes helps to replace a sub-expression of a function by a single variable. Occasionally, it can help to replace the original variable by something more complicated. This seems like a reverse substitution, but it is really no different in principle than ordinary substitution. So this type of substitution is usually indicated when the function you wish to integrate contains a polynomial expression that might allow you to use the fundamental identities sine squared x plus cosine squared x is equal to 1 in one of three forms. So we have three forms of the fundamental identities. First one is cosine squared x is equal to 1 minus sine squared x. The second one is secant squared x is equal to 1 plus tan squared x. And the last is tan squared x is equal to secant squared x minus 1. So we have heard the table of trigonometric substitution. So dili nato mahibalaan kung unsa atong gamito na formula or expression. So we have heard the first one expression, square root of a squared minus x squared. Ang iyang substitution is x equals e sine theta. Ang iyang differential is dx is equal to a cosine theta d theta. Ang iyang identity is square root of a squared minus x squared is equal to a cosine theta. And ang iyang inverse of substitution is theta is equal to sine inverse or arc sine the quantity of x over a. So, the same lang siya sa the second one and the last one. So, examples. Example sine substitution. Evaluate integral square root 1 minus x squared dx. So, we have heard the solution. So, let x is equal to sine u and dx is equal to cos u du. Then an integral of square root 1 minus x squared dx is equal to integral square root of 1 minus sine squared u cosine u du is equal to integral square root of cosine squared u cosine u du. So we would like to replace square root of cosine squared u by cosine u, but this is valid only if cosine u is positive, since square root cosine squared u is positive. Considered again the substitution x equals sine u, so we could just as well think of this u is equal to arc sine x. So if we do then by the definition of the arc sine, minus pi over 2 is less than equal u less than equal to pi over 2. So cosine u is greater than equal to 0, and so we are allowed to continue and perform the simplification. So example sine substitution. So continue lang ni siya sa diri ana examples. So integral integral cosine squared u cosine u du equals integral cosine squared u du. Then substitution na dayon. So, integral 1 plus cosine 2u over 2 du is equal to u over 2, then plus sine 2u over 4 plus c. So, arc sine x over 2 plus sine the quantity of 2 arc sine x over 4 plus c. So, this is a perfectly good answer to the term sine the quantity 2 arc sine x is a bit of unpleasant. It is possible to simplify this using the identity sine 2x equal to sine x cosine x. We can write sine 2u equals 2 sine u cosine u is equal to 2 sine the quantity of arc sine x square root 1 minus sine squared u is equal to 2x square root of 1 minus sine squared the quantity of arc sine x is equal to 2x square root of 1 over 1 minus x squared. So the full antiderivative is arc sine x over 2 plus 2x square root of 1 minus x squared over 4 plus c is equal to arc sine x over 2 plus x square root of 1 minus x squared over 2 plus c. So that's it. Thank you.